Hi, sir. Afternoon.
Hey, Paz, what are you doing?
Hello.
How are you?
I'm okay. I'm okay. I realized that my earphones was still at the computer. So I wasn't hearing anything first.
Okay.
Yeah. Um. All right. So I tried selecting my courses yesterday, and I
Mm-hmm.
realized that the work experience on Saturday, for some strange reason, it's saying that it cannot select the work experience for Tuesday because the one on Saturday was already selected. It's saying that there is a clash.
Mm. Is it two different groups? Because there's two different groups that can't go in there now.
Well, maybe that is the case, but I'm not sure because
But you never
classes
had
haven't been held.
no man what work
No,
experience was on Tuesday? Was it Thursday?
no, we didn't have any classes from since it started.
Right, but did I not did Michael communicate with you guys?
So yeah, so I'm not sure. Huh?
Did Michael communicate with you guys?
Yeah, he told us that Mr. Perry would start having classes.
Right, because Mr. Pate responded to the message that you gave me that I sent to him on Wednesday, on Tuesday, whichever day, on Tuesday.
Tuesday. Yeah, yeah.
Right. So he responded to say that he had only now just gotten at the time a copy of the timetable, knowing that he was supposed to be teaching you guys. So he will start classes
Okay,
next week.
okay.
So maybe
So
maybe that is a part of the problem too. Maybe not even seeing that time on it yet. The day on it yet.
yeah,
Give them a few because I asked Michael communicated me today, and I used the opportunity to ask him to check the timetables to see if it is reflected.
updated. Yeah.
Right, but he said no. So I asked him when was the last time that was updated, and he says it the 19th of January. I said, okay, the change that I did was on the 21st. But now that I'm looking at
Yeah.
the list that came out for the class Zoom,
Mm-hmm.
I'm seeing where it was done for both. Let me just see if I can go back. It was done.
Good
I don't know
afternoon,
if you
everyone.
yeah, how you do.
The afternoon.
I don't know if you have if the list that is sent out to you is the same something similar to what is sent out to us as faculty. But when I look at the chemistry and the environment, I'm seeing
Mm-hmm.
year three and year four to it. So it means that the change that I did took effect. And
Okay, so we can check.
when I look at the research methods, I'm seeing where it is in environmental year three, environmental year four, and the two HET groups. So there are four groups on it now. So that is reflected on the let me call it now. Let's see if I can. Research methods is just on the research methods. Chemistry and environment is 55. Research methods is 56. Yeah. So I'm seeing NVI3 and NVI4.
Yeah, still not seeing the changes though.
No, 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 no. I'm asking you. Look at the yeah, Mikey, check today and didn't see, but look at the Zoom links that were sent out, how they were sent.
Hold on.
Is it
Let me
as if
check.
everything was sent one and then you just select the one that you're a part of, or it comes directly to you for the class? Only your class, that
Um,
is.
no, it's hold on. Yeah, so it was just in the student class guide. So we just selected it. You can select all of the classes are there for
Right. So
anybody
that's
to
what I'm
select.
saying. Look on the section.
Mm-hmm.
Look on the section now for me, please.
Yeah.
Look at chemistry and
Okay.
the environment and look on the section. And tell me what groups are you seeing there on the section.
Uh, yeah, I see ENVI 3 and ENVI 4.
Yeah, man, it did
Good
it,
job.
man.
Yeah.
So
It
that's
did
what
it
I'm
on
saying to you.
the master list.
That's what I'm saying to
Okay.
you that the changes that I did
Mm-hmm.
took effect. It's just that the ones online is not yet updated because the last
I
update was the
understand.
19th, and I did that on the
Eh,
21st. Also, look
Yeah.
for research methodology now and see if you're also seeing invite 3 and invite 4.
Yeah, I'm seeing that as well. Yeah.
Great. All right, now. So let me, and I can't see work experience because work experience would not be generated now because today's not Friday or Saturday. Because which day was it? Tuesday, say? Which day were you supposed to have it at the session?
Tuesday and Saturday.
Tuesday or
Yeah.
Saturday.
All right, so you won't see it, you wouldn't have seen it on Tuesday because Tuesday I made a change when the list came out. So we need to look on the Saturday list now to see if we are seeing N by 3, N by 4. And they can just send me a message. If we're not seeing it N by 3, N by 4, it means that the change was not done. And then on Tuesday, we also need to look for N by 3, N by 4 on it. I believe the changes were done because I'm seeing it on the time. I'm seeing it on my side of the timetable, But it's just an online version. It's not yet updated.
Okay. Asia pointed out to me as well that the registration would have closed on Friday for the courses.
Don't worry about it because I can verify. They will be able to see on the system that I did a change to the timetable on Tuesday. So,
Okay. Okay.
so you see what I'm saying? So
Yeah.
I added the chemistry because the chemistry wasn't on your. Well, there are no year 3 students in the group. Are there? Is Carol year 3?
No, no, no.
Right. So there are no year 3 students in the group. And it's only year 3 had the time the environmental the chemistry and the environment on it, right?
Chemistry. Mhm. Yes, sir.
Good. So all of you are year 4, and it's only on Tuesday this week that I added the chemistry to your timetable. So they will when they go on the system, my footprints will be there, so they can see that I did just add it. So they can't charge you for that. I also just added on the 21st the research methodology, so they can't charge you for that. What they may say they can
Okay.
charge you for are the other 2 courses that were previously there. Did you select those 2 previous courses?
Yeah, I selected all the other courses.
Really good then. It's just that if you made no selection, period, when the other courses were there before, you may have a challenge, but for sure, they won't charge you for the stuff. So I will just bring that to their attention. Tomorrow. Um, yeah, I'll do that tomorrow so that the necessary changes can be made. So you can go ahead and select your courses. Any
Okay,
other
sir.
issue? Any other issue?
No, no, not for me.
You've got all the grades already?
Only got one so far.
Which one?
Um, Administrative communication.
Okay. Strange because I spoke with Mr. Walden and he said that he submitted the grade, so I don't know why it's not approved. I have to follow through on those tomorrow. Miss Dunbar taught you what course last semester? Forestry, right?
Forest.
Yeah, forestry.
Yeah, I know she is supposed to be finished as well. I was saying to Mr. Waldo yesterday when we chatted that, the good thing about it with you guys is that your grades will come in quick or should come in quick because there's not a whole lot of students. As we speak now, what I'm doing is, as we are having this present conversation, is to try and finalize some grades because I had like 1 million students in a pre-calculus class, and it took 1 million days to mark. So I just now today finish off all the markings and trying to put them together. So the challenge is what I should have done earlier is to write the grades of the electronic papers that were sent to me, but going back and forth is tedious. Anyhow, we are here. I am happy that your timetable issues are sorted. And it is now 12 minutes past, and there are only still 3 of us. All right, let me give a couple of minutes now for the others to come in, and then we can start.
Good afternoon.
Yeah, afternoon, Carl.
Good afternoon, Carl. Carl, why weren't that my meeting a while ago?
You know, see me text in the group, Michael. I text in the group.
No, well, I still not No, I died 5 o'clock when I'm after. You want to beat me, man?
All right, so good afternoon again. I didn't know that Asia got here. But, we're going to look at the where we looked at some experiments on Tuesday. And then we spoke about smoke in the atmosphere. We also spoke that smoke particles are much larger than the water or air molecules, and that the particles can be seen by the light they scatter. Remember also that the molecules themselves are too small to be seen. So the light in and of itself will highlight the site there. Also note that the irregular movement of the visible particles of smoke is explained as being due to the uneven bombardment of the particles by the invisible molecule of water. And this is all due to a process called Brownian motion. So that's one of the things that you can go into the exam and they can ask you to explain, given suitable examples.
Sorry, you're sharing, sir?
No.
Oh.
So
Sound like
they
it's
can.
really wrong.
Oh no. So they can ask you to. They can ask you to explain, given suitable examples, osmosis in osmosis. They can ask you, given suitable examples, Brownian motion. That's the smoke particles in the atmosphere, or in water. They can ask you to explain, giving suitable examples of diffusion in air or liquid. So you don't know where it's coming from, but you just have to know what it is and be able to explain it as you go forward. All right, so let me go again. They can ask you to explain by giving suitable examples, Brownian motion. They can ask you to explain by giving suitable examples of osmosis. Explain by giving suitable examples, diffusion in liquids and in gases, right? And of course, you can use the experiment that we saw earlier, not well, on Thursday, on Tuesday, sorry, with the hydrochloric acid and the ammonia, with the ammonium chloride being formed in the center. Also, if they ask you to explain, you must be able to speak about the density of the gases. And because one gas is more dense, it's moving slower than the other one that is lighter. If it is that you're talking about the diffusion in liquids, you have to talk about the solubility. The density also plays a role. Am I speaking anything that you don't know now?
Understand.
Yeah, man. So I explained the stuff in class. It's now your responsibility to read and to get a fulsome understanding as to what is expected of you. Because you can't just come and just say, Brownian motion is this. No, you have to give me something that is um, substantial, something that it has meat to it. All right. So what I'm giving you is just enough to explain the concept. What you now need to do is to go and find the information so it is that you can have what it is that is going to be required of you. Am I clear?
Yes, sir.
Crystal.
Are you with me or are you with me?
Yes, sir, we answered.
Yes,
Oh, I
sir.
didn't hear you. I didn't hear you. Let me ask you a question. This is the trivia for the day. When you walk across dry sand, you sink. When you walk across dry sand, you sink. But when you walk across wet sand, you do not sink. Think about it. When you walk across dry sand, you sink. But when you walk across wet sand, you do not sink. 2 minutes thought process, and then we're gonna have a conversation. I'm stepping away for about 2 minutes. I need to go and get this charger before it goes. And then I need to project what it is that we're going to be discussing today. What will be discussed today? What will be discussed today? So I can just run through this pretty quickly. And then won't be spending much time on this. Matter of fact, I'm going to see if I can finish off this part today. Yeah, so I'll just do this for today. Alrighty. Mhm. Alrighty. So I think all right. Any possible solution yet?
No, sir.
All right, so I'm thinking that the wet sand would be, the particles of the wet sand would be more compact and tighter, closer together than the dry sand, and that's why you would be more likely to sink in the dry sand than the wet sand.
Okay. Another suggestion?
Okay, sir. So I would say that the wet sand, the reason why you would not sink is because you have more between the particles of sand, you have air and water that would occupy that space. Thus, which would give you that kind of solid platform. While in the dry sand, you mostly have air. So when you step on it now, you're basically forcing out the air, which compacts the sand.
Okay, all right, thanks. Anybody else?
Sir, at first thought, I would have thought that adding water to the sand would increase like the density of the sand. So instead of regular sand where you step on it and the density would not be higher than the density of our bodies. So it would like give way to the weight of our bodies. But then wet sand would be dense enough or denser than our body weight and keep us upright. That's what I would have thought.
Okay. Carol, that leave you now, you know.
Sir, because that is really confused because when you said dry sand, it what you say again? It will sink
Mm-hmm.
and wet sand.
Yeah, when you go to beach and walk on the sand and you step in the sand and you sink at the bottom. But when the sand kind of wet, it keep you up. So,
Oh, can me I think about it the other way. Me I get it confused.
So what is the answer then?
As like so with the example with the at the beach and your foot bottom it wet, it keep you more the sand wet, it keep you more it's sturdier. So when you walk on it, your foot don't like go down in it as compared to when you walk on the dry part and your
Why?
foot with the water. Is it salt water?
You never tell us if it's salt water or fresh water. You just say water.
Because water, sir.
Sir, may I get one more try?
Go ahead, let me hear you.
All right, sir. So now think about now, and remember one of the properties of water is that it is a cohesion or something like cohesive.
Mm-hmm.
So basically, when it would like work together to like hold the particles them together, so it's more stable. While with the sun absence of water, you don't have that support system. So again, it would compress because you have nothing to hold it together. You don't have that cohesive force. So I think back from a chemistry perspective along the line of the property of water.
All right. Okay. So in a nutshell, I think you guys have gotten it. I just needed to hear from from all parties so that I don't just say, yes, you have it, and then that is it. So, right. So in dry sand, you have air spaces. Agreed or disagree?
Agree.
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 So when you
Agree.
step on it, you're actually compressing the sand. So you're pushing out the airspace. So when you step on it, it's weight that goes on it. So you're actually pushing out the air particles, the air particles, and actually compacting the sand. So you notice when I don't know if you've been on the beach before, when they've just raked it and it looks all clean and nice, and you're there walking and you just go all the way down because it's a lot of air particles that now fill up the sand. Do you remember the conversation we had uh with the rice and the sugar and even the flour and the cornmeal? When you hit it,
Yes, sir.
you're actually ordering the direction of the particles. So the particles are being ordered in the same direction. So therefore, it is reducing the air spaces between particles, the sugar crystals, the rice grains, etc., etc. So therefore, what it does now, it's causing that sort of compactness in it. So you can have more, the air spaces that you would normally have, it is now filled up with more sugar crystals and salt grains and rice crystals, or rice grains, etc., etc. Right? So you're squeezing out the air spaces in the dry sand, as opposed to the wet sand. The spaces in the wet sand are filled with water molecules. The water molecules pretty much are binding the sand crystals or the grains with the water molecule. So they're almost in equilibrium. So it feels very compact. It feels very compact. And in order for you to dig it, you have to use quite a bit of energy to dig, as opposed to dry sand, because there's lots of air spaces between them. Does that make sense?
Yes, sir.
Yes, sir.
Come on.
So all of you pretty much gave me the responses I was looking for, and congrats. So this is what I want you to do. I want you to think. I want you to think outside. Students, when you go out into the place of work, there are going to be things that you come up with that you'll need to know. So for example, you can go in your bathroom and you go put fabuloso and chlorine in other people them toilet if you say you're going to clean it, because it is going to cause a reaction. So you have to know the constituents of the chlorine. You have to know that it is very reactive. And you also need to know the constituents of the fabuloso, right? It's going to foam, and you're going to have a production of some gas coming off. Now, the gas that comes off could be very toxic. Could be very toxic. And if it is that you have respiratory issues, and especially if you go clean it at night, dog na me supper. So you have to be very mindful before you combine things together. Very mindful. And this is going to be in your area of the stuff. So you could be an occupational health and safety person, and the cleaning people them doing them stuff. You have to say to them, yo, don't mix them two chemicals together here, or put it in this ratio, or whatever the situation is. But you have to be mindful of what it is that you're doing, or else you can cause problems. You can cause problems. So so before you go ahead and issue anything, you have to know what it is that you're doing, or else you can cause harm to body, to building, whatever it is. So you have to be careful. All right. Hold on a minute for me, please. I need to step. All righty. So what is going to happen now is I really want you guys to be reading. I want you guys to be thinking outside of the box. I was saying to you, there are things that will come to your attention that you must deal with as a person who is the environmentalist in the organization. That's just it. As a person who is an environmentalist in the organization, you must think outside the box. Hold on a minute. Right. So what I'm saying to you, students, is hold on. All right. Sorry about that, you guys. So one of the things that I want you to remember now, as an environmentalist within the organization, the institution, you are going to be a go-to person. If, for argument's sake, there is a problem with the sewer, don't think say too nice. Tell you, Carol, stushy. You have to go talk to the people them and tell them what to.
Sir,
Yes,
what?
ma'am.
Sir, oh, you know, it's a mixed tush.
You stushy. You know, stush.
No, sir, not all that.
All right. All right. Never mind. You know, not all that, but you're semi-stush then, right?
Yes, sir, yes.
Yeah, man. Yeah, man. But seriously though, we have to be able to know the stuff. So if there's an issue, you have to go read up on it. So because the truth is, let me tell you what the truth is. You can be called to give a report as to why something has happened. So if you are working with NSWMA and there is a land fire going on, and talking about land fires, let me tell you something. The amount of houses that I'm hearing are being burnt and burnt down. A student lost her house recently. A staff member lost her house last night. A co-worker lost a section of his house in December. Two of my mother's friends lost their houses, and this is in recent times. I don't know. I'm wondering if I'm living in California, because the amount of fires. And then one of my friends was saying to me, co-worker was saying to me, sir, I saw when the fire brigade fly past me, and I never knew that it was my house the fire brigade was going. Is when I
So,
got a
sir, this is
telephone.
something that usually happens every year in Clarendon, right? Or St.
No man,
Catherine?
no man, this is in Kingston I'm talking about.
Or Kingston?
Kingston and St. Andrew, yeah, man. So I don't know, something is happening. A lot of people, and it comes back to the point that I'm now making. A lot of people believe that in order to get rid of their garbage, they're supposed to burn.
But that's not always the way, sir. Well,
It
that's not.
shouldn't be the way. So you used a wrong word a while ago. Always. It should not be the way.
Yes, sir. I was going to correct it and say it
You
should
should
be.
never burn your stuff. I had one of my neighbors, Jesus Father, I nearly died. I'm saying to myself, who light fire? I couldn't breathe. And when I checked a stop, I said to myself, I said, no, man. And I went and I called her up. I said, why are you burning? It's against the law. I said, you're killing me over here. This is my house. And I am uncomfortable because my chest is tightening upon me. Oh, it's
Especially if
not me.
it's plastic.
Oh, Jesus.
The
We don't go
toxins
there yet.
released from the plastic.
We're not going there so yet, pause. And then, no, I said to her, oh, is not she is one of her tenants. I said, well, tell him for out it no. And I said to her, I said, let me tell you something. If ever you need garbage bags, don't be afraid or ashamed to come and ask me for garbage bags. I say, even if it's leaves, bag it up and put it outside. They will take it up. They will take up the leaves. They will take up the other form of garbage. Don't burn. And it not care how me talk to her, is the same thing over and over and over and over and over. I was leaving
Sir,
the house. Yeah, go ahead.
yeah, but quick question, because you mentioned that it was against the law to burn garbage, right? But
Mm-hmm.
how many Jamaicans are aware that that is a law?
They need public education. So people like me and you need to go and educate them that this is wrong. Because you see, let me tell you, when it is that you burn, what happens? Earthworms that are very useful to aerate the soil, ants, lizards, and all those other creatures that are used to aerate the soil. So it is that you can have percolation of the water into the roots of these plants so that they can live and thrive, are going to all die out. They are going to die out. So you're going to have a soil now that over time is going to become acidic. And as a result of that, you're not going to be able to plant, and that the fruit trees and the vegetables that you want to grow is going to come to anything. So it's a ripple effect that it has on the environment. Let us not even talk about the respiratory issues. Really serious. Let us not even talk about a spark getting to your neighbor's house, falls on the roof because it is windy when you light the stuff, and lot of sparks in the stuff, and something fly over your neighbor house and go up on top of the roof. Your neighbor don't know and you don't know. And it land on a piece of termite wood for your neighbor rooftop. That is just saying, send me the spark so that I can be lit. And then all of a sudden now, you see your neighbor's rooftop upon fire. Remember, I said termite, so it means it not sturdy already in and of itself. The next thing is that one section of the roof cave in on the people then. God forbid you have a child in there sleeping and everything cave in on that child, or a senior citizen who is not very mobile. Serious something. Serious something. You have a dry piece of branch that hangs over your neighbor's house as well. And the flame travels all along there. So I believe the cases of these, and then of course, yes, we know we have the electrical issues that, is another thing that people need to go on and not bridge light, and they need to every now and again get their houses inspected. If especially if the thing is compromised, the wiring is compromised, so that we can do the stuff. If you have any doubt, check it out. Yeah? But it is very dangerous. Has made mention of the toxins now. People burning chlorine bottle, the PVC in the container in and of itself is releasing toxins. But the chlorine, liquid chlorine, when heated, those particles become volatile. And they receive so much kinetic energy that they move, and you and I inhale that. It is acidic. We can have chlorine poison just by the fact that somebody is burning a chlorine bottle or several chlorine bottles. We stay over in our house and have chlorine poison. I don't even know say chlorine poison we have. Aerosol cans. You have big explosions because the gas particles in there swell, and they swell, and it's the swelling of the gas particles that have nowhere else to go. Pressure bust pipe, it's going to burst the can. All of those gases now combine together. Chances are you have a new compound that is being formed that could be very deadly. Eye irritation, skin irritation, respiratory irritation. It's a whole lot of things. It's a whole lot of things. So we have to know what it is that we have to know. So it is that we can do public education. And the public education is to say to people in the communities, you are not supposed to burn. Behind me, where I live, behind me is a commercial building. And oh, I regret living behind a commercial building. To my left, to my right, and in front of me, you have dwellings. Because that commercial place, when you're collecting garbage for commercial, it's more than residential. But residential you don't pay for, because that goes into your taxes. All right? Your property taxes, it goes into funding to pick up garbage. Now, if you cut down a tree, don't expect them to go and pick it up. You'd have to pay especially for that to happen. But your domestic waste is taken care of by your property taxes and the other taxes that we pay. But when you're collecting garbage on a commercial level, so like Excelsior now, when we have enough garbage and we need to collect it, we have to pay them. And if we don't pay, it's not going to be collected. And if you don't collect the garbage, it is a haven for the reproduction of rodents, lizards, cockroaches, or flies, all those things. So it is what it is. It is what it is. And just to say another little piece here before I move back, let me ask a question first. How many of you separate your garbage before you send it out to be collected?
Oh, I have been doing.
I have always done that.
You've always done that, and you
been,
have been doing it, Paz.
Yeah, I've been doing that from since I was a child, because My mom herself is an environmentalist. So
Mhm.
she always told us to like separate um the plastics, the plastic bottle and the glasses. Um, well, first we used to collect the glasses and we used to just get money for them, but we also and still do separate the plastic bottles. So we have like a little bag in the kitchen and we'll put
Mhm.
those plastic bottles in there. So yeah, we do separate our garbage. Yeah.
Thank you, Paz. Thank you, Mikey. Ladies, what say you?
Sir, unfortunately, I don't really separate my trash. I just throw everything in one thing and put it out in the garbage around the front. And when garbage truck come, them just take it up.
Okay, so what are you going to do differently starting today?
Separate it. But say it can't be just me, no, me I forget my whole family them on board.
What are you going to do differently? That's what I'm asking you. It's education, so it starts within the home.
Mhm.
So you have to educate your family. So what needs to happen now is that you're going to have a different bag. So let me tell you how I do it. For years, I have been separating my garbage. So what we do is that we have one of those plastic bags outside that or liquid soap. The bottles are placed there. The cooking oil, the water bottle, the juice bottle, any bottle, the detergent bottles, any bottle is placed there. Matter of fact, if I have like a repellent in a can or starch or any of the sort, it is also placed in that bag. If the garbage truck is coming and the bag is only half filled, it is not going out. I'm going to keep it at home. The bag is tight, so if it rains, I don't have to worry about breeding mosquitoes. And then I'm going to empty it. All right. Now, there is a problem and there is a concern because when it goes to Riverton, when the truck goes to Riverton, everything is being emptied at the same place. In the great United States of America, I've been to other countries, but mainly the US. They have a separate garbage truck that comes to pick up the recyclables. So when I'm there and I go to good old Amazon to buy all these wonderful stuff and I'm carrying them back to Jamaica, and I'm not carrying them back in the boxes because it's weight and space, and I'm taking out, I have 3 big garbage bags filled with boxes. I have to sit down like I am packing and cut those boxes. And when I cut those boxes, I have to make sure that the boxes can fit into the recyclable receptacle. Because I can't just put the bag of thing outside it because you don't have garbage men like we do out here who is going to come and lift the stuff and put it there. No, you have to position the garbage truck, the garbage receptacles at a particular spot along the side of the road. The garbage truck comes there. Um, a mechanical arm comes out from the garbage truck, picks up that garbage contained receptacle and lifts it and empties the stuff in the truck and it puts back the garbage receptacle right where it's supposed to be. These receptacles are given to the residents by the city, right? So nobody can say, "Oh, I didn't have anything to put my garbage." No. And guess what? If when the guys come and they say, "Oh no, this receptacle needs replacement," I'm not going to put it back there. I'm going to make a record and send out something, and then 2 tools a new receptacle comes. And then what you're going to do is that recyclable, those recyclable waste is not sent into the general landfill. It is at a separate landfill. So what is going to happen is they The cardboards and the papers are going to be sent somewhere to be recycled. The bottles are going to be sent somewhere to be recycled. They're going to be crushed. They're going to be grounded. They're going to be sent to be recycled. The tires that they use are going to be sent somewhere else to be recycled. And it goes on and on. It goes on and on. When you have your old furniture, you know, so people throw them old bed and them old fridge out a door here in Jamaica. It doesn't happen like that in the States. I remember when I just got my driver's license and I felt like, yeah, man, I'm man now. And me want to drive go anywhere. It didn't tell me to drive to Jamaica and back to the US. No? Oh gosh, do I have to go now? Can we wait until tomorrow? Can we just do 3 things in one day instead of me doing it 3 different days? And I remember they were doing some renovation and they said, oh, we need to go to the dump. I said, I can go it. And we load up the car, load up the car with the stuff, and I'm driving to the dump, and and there's a line. And then I have to drive on I have to reverse on the ramp. And I'm in a reverse on the ramp. You have people there because some people are thrown beds where it's just 1 foot breaking and them decide to them not fixing it. It's not like Jamaica where you go take a man something and fix. Good beds. So you have people there at the recycling place to say, oh, may I have this please? They said, take it, it's yours. FOC, free of charge. All right. So, and this is why I know what they do there is that they have lands that are so identified as landfills. So they dig their holes and they put their waste inside of these landfills, and they do it in sections. And when one section is filled, they spray liquid grass, it grows, you don't have any smell. And when that landfill is pretty much filled now and nothing more can do it, they said, okay, fine, let us go and put some pavers, let us go and put some swings, let us go and put some gazebos, let's go and put a walking trail, let's go and put a little tract inside here, so forth and so on. And you have a nice community center. Anybody can go there, go relax. You can go buy your ice cream over here, so, and then after buying the ice cream, you can go over there, go sit down. You can walk your dog. It's a walking trail, a dog trail, whatever the situation is. And what I saw them doing last year, some of these landfill areas are being excavated now. And the houses are being built. So they compact the land and there are no building houses, residents. So these are areas that you have to know what it is that you need to know. You can't just SWOT and Google AI the stuff where you work for do and I get the good grades and then go there and say, oh, I did environmental studies. No. You have to go there and talk about these things, what you're not supposed to do, why it is dangerous for the environment, and how it is that you can now mitigate. If you don't take care of the environment will not take care of you. Full stop. Real talk. So, so what you need to do is you have to read, you have to know, you have to be in the know. You cannot not read and then expect to know. No work. So the information is not going to be diffused into your being. It's not going to diffuse into you. You have to read it and retain it. Am I clear?
Yes, sir.
Yes, sir, definitely.
Yes, sir.
And it makes a lot of sense, don't it?
Yes, sir, of
Yes,
course.
sir.
You know, one of the other things, one of my other pet peeves, I used to do it a lot. Jesus. But you see, ignorance is, what may I tell you, see? So, and it's bad company that caused it. One of the things that I'm happy about is that I never picked up the habit of smoking. But I used to pick up the habit of chewing my straws. Because me used to buy enough bag. Me used to love Sky
Yes, sir.
juice.
We still do it today.
No, not do it, Mamu. Not do it. Because when you bite up the straws, you're actually releasing the toxins, the carcinogens from the straw. Remember, it's plastic, you know. You're releasing the carcinogen from the straw
No,
into your
sir.
system.
We not do it, you know, because no paper straw now. I mean, I really buck up on so much plastic straw recently. I just the paper one them.
Which is true. It's mainly paper straw now, thankfully. Even though I hate them because if you drink a that predator, you make the straws, you know, there's something you can't,
Yeah,
they
it's
can't suck up
saggy.
on the outside.
It
Yeah,
gets
it's saggy, you
saggy.
can't do it. Yeah, so, you know, I have bought a set of bamboo straws. And every time I'm going to a hotel, like for a weekend or whatever period of time, and I am to take out the bamboo straws to carry with me so that when I'm going, I can have my own straw to drink from, is when we reach at the hotel, remember the bamboo straws them. Because
Sure, them
those
have
straws,
metallic ones as well.
and they have the
Like
metal
the
straw,
metallic, yeah.
yeah, man, they have the metal straws as well. So matter of fact, I'm hoping that when I get home, I can remember to put the set of bamboo straws, and I have some metal straws as well, into the car. Because it is annoying. When you go out, you go to a restaurant and you're having something and they give you, you know what people do? They sell these reusable straws in lovely cases, you know. So people are going to restaurants and they walk with their cases and they remove their own straws and they drink from the straws and put it back and go and wash them and put them up for another travel. Right? Because yes, I agree. We can't we throw on the straws and we throw on the straws until it turn bubble gum. The only thing left with it is blow bubbles with it. Unsafe. And you know what? But it's also unsafe. I saw somebody do it and I was like, seriously? What they're doing is like when they're catching up coal, them use a plastic bag to catch a coal with it. And then them stand up over it and either blowing into it or fanning it. And I'm saying, you are now inhaling. Sorry. You are now inhaling all of those toxins. I say you are now inhaling all of those toxins. So we need to stop it. You know, one of the other things that I see people do, and we need to stop. You see, and that's why, guys, oh boy, I need to get back to this. People used to put plastic bags over their rice so that you can crack the greens of the rice. So you don't have piece tough and piece. And sections of it cook and sections of it don't cook. Dangerous. Because that rice now is contaminated with lots of toxins from the plastic bag in and of itself. So you have to be careful of the things that you do. You're warming up your lunch, your leftover lunch in the styrofoam container, the coffin boxes that you buy your lunch in.
Yeah,
And
I'm aware of that one as well. Yeah.
you can't do that because you're breaking down the box. A section of the box is being melted, you know. So what you're technically eating is the plastic styrofoam. Can't do it, man. Dangerous. Dangerous stuff. All right. All right. So what I want to look at is tonight, and I'm still going to do it and finish it. We're just going to have a conversation on pure and impure substances. Pure and impure substances. And it's not going to be long. But again, I'm going to ask that you read, and you're going to be reading and reading widely. Pure and impure substances. So pretty much, technically, all of matter can be classified into two main categories. Either it's pure or it's impure. It's either pure or it's impure. And the term purity has a quite different meaning in chemistry than in our day-to-day life. So normally when we refer to pure water, for argument's sake, or pure milk, it is implied that water, milk, etc., are free from harmful substances. For example, our bacteria, fungi, and viruses. So pure in chemistry is different. So when you talk about pure, you talk about pure bulk syrup. People think about pure bulk syrup is thicker because it's more syrupy getting in it. Mark, I'd agree with it that it's a little bit more concentrated than the Grace one because it just need like a tube. So, Carol, is which syrup they used the other day? Grace or pure or pure or bulk? Pure bulk. Oh, gone, she's gone, you know. Carol!
Me no gone. I'm not gone, sir.
But me ask you a question and you not answer me.
Sorry, sir. Never that. Means
Yeah, me know.
you just see that.
You need to pay him no mind. That's it.
Repeat the question.
Yeah, me know. Yeah, I said, sure. This a man I going with the class and the class we done, you know, I mean want to
No,
go.
sir, me not say that. Me just did that steer.
Aye, sir.
Sir, can you repeat the question?
No, I'm just saying, which of the syrup you used the other day?
Oh, I forgot checking out, but it's like it's not the hold on. It's I don't remember the brand, but it's in like the medium size long bucket, the narrow. Let me explain the bucket. The top of it long and narrow, and then you have the bottom, which just
So you're saying to me that you buy no name brand syrup for drink?
no. Sorry, when the syrup them here, I don't normally drink syrup.
Okay, got you.
Yes, sir.
Got you. All right. So when we say that a substance is pure, it means that a substance is made only of one type of constituent particle. So when you talk about pure syrup, not syrup, yeah, pure syrup, and you talk about pure honey, you know the wicked man them do? Anybody know what them do with the honey? Wicked. Anybody knows?
Add sugar.
Wicked.
Yeah, add sugar tea.
Wicked. Yeah, you're right. They add sugar to it. And how do you know that they add sugar to it? Can you taste it? How would you know? Let me see if you. How you know that sugar is added to it?
You know, Michael.
No man, we know pay for it, man.
What was that, Paz? What you said, Paz? Paz, you said something. I didn't hear you.
Or maybe
No, I was asking how you know the difference when they add the sugar.
No, that's the question I'm asking.
Yeah, I'm asking how does he know?
when it crystalline
Or
and it get
crystalline.
thick. When it get thick, when it
And you just end it like that. That's all. All right. So you are correct, Asia. You are correct. So let me tell you what happens. So when you have your honey, just place it, the one in the bottle that is, just place it on the countertop. And after you place it on the countertop, if they've added sugar to it, you will see the sugar crystals precipitating out in the honey. And especially when you try to open and close the bottle, you see it has, little grainy stuff around the bottom mouth. Those are sugar crystals precipitating out of the, yeah.
Sorry, sir. Me still go get information, sir. She buy Cal's or bulk syrup.
Yeah, man. Tell him, man. Yeah.
That sound like the culls. The bottle where you describe sound like his culls.
Yeah.
Right. So what they do, they add sugar to it and then sell you as that, and it defeats the purpose. It defeats the purpose if it is that you're only allowed to take honey and not sugar, and I am going to sell you sugar as a substitute. Really, I am not being genuine. So in chemical terms, pure water means that it is made up only of one type of molecule, that is H2O. Right? Only H2O. But nowadays, it mixes up with everything else. So understand what pure means in chemistry, right? So pure substances can be further divided into elements and compounds. And impure substances only are commonly called mixtures. Because it has other constituents. Right? Remember, if it is pure, it is made up of only one type of constituent. If it is pure, it is made up only of one type of constituent particle. If you have many more constituent particles, it's now a mixture. It's now a mixture. All right. And then now that can be further divided into homogeneous and heterogeneous mixtures. Homo means
Same.
Right. And hetero means different, don't?
Yes, sir.
All right. So let us look at this thing here and see if we can dissect it a little bit. So matter, basic constituents, can be either pure or impure. Matter can either be pure or impure. You talk about pure substances, we're going to go back to the nitty-gritty. What is nitty-gritty? Elements and compounds. Elements are like what it is that sir is going to ask you guys to study. Your hydrogen, helium, lithium, beryllium, boron, carbon, oxygen, nitrogen, fluorine. All of those, you must know the first 20 elements of the periodic table. And you're going to go right down to its elements. And then we have compounds. We met some. Ammonia, NH3, hydrochloric acid, HCl. Those are two that we met recently on Tuesday of this week when we did the labs. All right? And then now when you talk about mixtures, hey, this is where it becomes what do you call it now? Interesting. So for our mixtures, we can be homogeneous, it can be heterogeneous. Right? For example, our homogeneous solution could be like a mixture of salt and water. Could be salt and water. And our heterogeneous mixture now is soil, wood, and the likes. But guess what? For elements, we can go even further, a little bit more granular. And how much granular can we get to that? Metals, non-metals, metalloids, noble gases. All of those you will study on the periodic table. I made mention of them on
the Tuesday.
On Tuesday, right. Good. So it is that we can, just finalize those noble gases. I spoke to you about noble gases, spoke to you about the metalloids. The metalloids are the ones that share both metallic and non-metallic properties. Stick up in. I pause somewhat because something comes to mind. Guys, you see, when you're in this field, you have to be a reader. You have to be attracted to things like National Geographic Explorer. You have to be attracted to news. You have to be attracted to things because things are ever changing, right? You you have to know your fossils that are now coming up, you have to know this stuff. You have to be reading. You can't just sit down and just say, yeah, I'm done. You have to read. If you're not a reader, you watch these documentaries. So it is that you can stay informed. Do you know that? Well, let me ask you the other way around. What is really bronze? You go to the Olympics or the World Championships and you came third, or you're doing a swim meet and you came third, and you're awarded a bronze medal. What is bronze?
Bronze is a combination between I think it's tin and copper. It's not
Is it just
not a
is it
fuel.
just is it just tin and proper tin and proper tin and copper?
I guess others are included. I'm not sure what
Absolutely.
others.
That is what is called a heterogeneous mixture. I'm trying to remember where it was, which of them. It was the last Olympics, the one that went last year. Some of the athletes are saying that by the time they got back to their home country, their bronze metal started to strip. And I remember when it was in Tokyo, the Japanese, them said something like, because they recycled cellular phones, they use the recycled materials from the cellular phone to create bronze medals. So, one has to be very creative in how it is that we in how it is that we do in how it is that we recycle stuff. Life is a cycle. So don't just throw something them down like that. Yeah, yo, here the plan. Olympics are coming up, or we're gonna have. One of the things that I keep saying, and every year I ask my students if they really want to come on board, and them say no, and then I just leave it. I just leave it as it is, and here I know again another school year about to make that recommendation. One of the things, and I'm going to put it out there because it really don't mean much to me. Yes, there's money in it. So if you want to run with it, is your business. If you feel like you want to give me a cut out it, that would be nice. But if not, have fun. Every year I'm teaching chemistry and the environment, and I'm saying to myself, what can I do with these tire shops and mechanic places that have these many tires out there breeding mosquitoes and so forth and so on. And I said to myself, you know what? I'm going to invest in a shredder. I'm gonna get some workers who can, because you know that the tires have wires in them, right?
Yes, yes, sir.
I'm gonna get, I
No,
said that I'm
according
gonna
to
get,
wire, it gives it stability.
yeah,
Yeah, the wires actually give it stability
the
and
stability,
shape it.
right. So I said to myself, you know what? I'm gonna get these things. I'm gonna slice these tires. I'll have somebody who can sit and just peel the wires from it. The wires can be used to do many things, I believe. And then now I'm gonna shred these tires. I'm gonna shred them and color them. And instead of using pebble sand for sand pits in prep schools and them something there, we can use these shredded tires that to do some stuff. But walking mats, you want to create a trail. You fuse these shredded tires together, and you shape them into whatever shape you want, square, rectangle, and you make these walking pads and make them thick enough, and you make these walking pads that you can move from your house to the side of your house to the back of the house, whatever the situation is, so forth and so on. Recycle stuff. We happens the way they is the set where they dump the tires, burn, and the plumes of thick smoke emitting carbon. The environment is crying out. And see, the president of the free world now again signed an order to exit the United States out of the climate talks, but that's another conversation. All right. So I have a little thing here for you. And, for example, we spoke about honey originally, initially. I want you to be able to differentiate between pure honey and impure honey. And yes, we can. So one of the things you can do is to pour a half cup of honey slowly into another cup. Slowly into a cup. The pure honey will spin clockwise as you pour it. Trust me, we don't know why, but it has a clockwise spin if it is pure. And the result is going to be asymmetric of an asymmetrical structure of honey molecules that gives it the right hand bias. If it is impure, it's not going to go clockwise. And then you can test the water content of your honey. To do this, just dip the length of your cotton wick into the honey, hold it at one end, and allow the excess honey to slowly dribble off. Light your candle, and then hold it to the soak end of the cotton wick. And if your honey is pure, it will contain minimal water content, and it will burn. If it is impure, it will likely to have a high level of water content, which will prevent it from burning. But you and I are not going to go through all of that when we buy our honey. All right? We're not going to go through all of that. But I'm just saying that, yes, we can test the purity of those stuff. And there are other things too that we can use to do that. All right. So let us move into some mixtures, those that are homogeneous, those that are heterogeneous. So a mixture really is a combination of two or more substances that are not chemically combined, and they do not exist in fixed proportion to each other. Sugar and water, salt and water, right? It's a mixture. They're not chemically combined, so therefore I can separate the water from the sugar. How would you separate water from sugar? Sorry. Yeah, go ahead. How do you separate water from sugar? You have a sugar solution, and I say to you, hey, I want to separate this water from this sugar. What would you do?
Apply heat.
Okay, apply heat. What happens when you apply the heat?
So heat will actually evaporate the liquid, and the solid will form as that concentration increase.
Okay. Anybody else?
Sir, that is when the sugar is not mixed in the water.
No, man, you have the sugar solution. You have the sugar solution. So I give you some sugar and water. And I say, yo, separate the sugar from the water for me now. And I'm here now, you apply heat. And you drive off the water molecules. And then what is remaining inside there is going to be your sugar crystals. And I'm asking, are there any other suggestions? Talk to me now. Hello, somebody.
Sir, I think that would have been the most common method, sir.
But you heard my question, though? What was my question?
Yeah, if there are any other solutions.
My question is, how do I separate water and sugar from a mixture of sugar and water?
So as Michael said, when you add heat, so if you're boiling the sugar water in a pot, if you evaporate, if the water evaporate, if you leave the water to evaporate, then the sugar will be left behind. I guess if you do it at a steady pace.
So okay, yes. So the sugar will be left behind. Yes. Hooray, hoorah. Got that. So tell me now, how would I be able to get my water molecules?
Sir, oh, you condensate now, the steam.
No, so say it no, man. Just tell me the something, no? Just tell me the something. You have to know, run it through
A
using a
condenser.
condenser. You have to
Yeah.
use a condenser. So you are going to use an apparatus that you can cover it. When the steam comes, you're going to have cold water in, and you will have a section where the water comes out because what you're doing, you're cooling the steam. So when you cool the steam, it comes off as droplets of water in a beaker or something. Yeah, no, makes sense.
Yes, sir.
So you can't just put it in a pot and boil it, because when you do that, the water vapor is going to come off. The water is going to come off as water vapor, and that
Yeah.
gone. You can't catch it back. So all you're
Yeah.
going to be left with is just sugar and no water. Follow me?
Yes, sir. Make perfect sense.
Yeah, man.
Yes,
So
yes.
you have to go get your stuff. Now let me come back to a point here now. So when they get the crude from overseas, Petrojam gets the crude from overseas, and they're processing it. You have different levels that we are going to be getting off stuff. Bitumen is what we use now, otherwise known as tar, is what they use, of course, to make roads. And lots of people use it in for roofing materials. If you have if your roof slab and you have leak, you're gonna put some tar up there because it's believed to take care of those challenges. All right. You're going to have your 87 octane coming off. You're going to have your 90 coming off. You may have some low grade alcohol come off. So you're going to have different fractions, we call it. So at different fractions, you're going to get off different stuff. So you can't have the octane level coming off at a fraction other than that one. So it is very specific. So when you process the stuff, you will get some 87 out of it, and you'll also get some 90 out of it. And then the waste is going to be your bitumen, that black tarry-like substance. Yeah, man, the man them save that, man, I use it for road construction.
Yeah, man, asphalt good.
That's right. And you don't know what is happening here, Mikey, or maybe you hear about it, but it takes hours to get from place to places. No matter how short a distance it is, because of the road conditions and them repairing the roads, and it's just not a nice thing to travel now. It's awful. All right. So
Sir,
now,
the amount of patrol that they out there now, as you know.
oh Jesus of mercy, no sir. All right. So of course I spoke about the two different types of mixtures, those that are homogeneous and those that are heterogeneous. A homogeneous mixture has the same composition all the way through. Example, a solution of common salt and water. All right. And then a heterogeneous mixture now has non-uniform composition, sand and water, for argument's sake. Non-composition. All right. And each component in the case retains its identity and properties. Now mix. So from the above diagram, what it is that we looked at earlier, a pure substance may be a compound, it can be an element. So a compound contains elements chemically combined in a fixed ratio, like H2O I need two molecules. I need two hydrogen molecules with one molecule of oxygen to form my H2O. And that's what my water is, right? So compounds will have definite properties and established formulae. So examples of compound, as I told you, there's water, sodium chloride, which is otherwise known as table salt. You knew that, right? That your sodium chloride, NaCl,
Yes,
is what,
sir.
right, is what we use as our table salt. And you'll recognize that the table salt now has they have like a salt factory out in Spanish Town. Oh Lord Jesus, I don't even think nobody can go there today. But anyhow, they have a salt factory. Now what them guys do is get salt water, put it in vats right at the place there. And when it evaporates, you have the salt crystals that are forming. And those are what it is that they use to sell as salt. Now, I don't know if anybody ever buys a bag of salt yet, and when you look inside it, the salt look dirty. Anybody have that experience?
No,
No,
no, sir.
All right, do me a favor. You see, when next you go to the supermarket, just walk, not the, of course, not the salt in the container that says refined. The back sea salt, just look into it and see if you sometimes you see some drops of impurities. You'll see it. And it's because of the process, how it is that it's done. When it is refined, on the other hand, and the grains are very coarse. The grains are very coarse. No, you can buy the refined salt where the grains are so fine, very fine, almost powdery. But the difficulty is it is processed and the iodine is removed from it. And of course, you know, our bodies need iodine to survive. So if it is that you're removing iodine from your system there, we have to find it in other substitutes, or else we're going to be sick. Or else we're going to be sick.
Sorry,
All
sir. You
right,
can scroll up a little bit for me. I just want to see something.
right there.
Yeah. Okay. All right. Thanks.
All right, now, so let us look at elements. And these are substances which consist of atoms, of all which have a nucleus containing the same number of protons. Example, you have aluminum, you have lead, you have sodium, you have hydrogen, you have oxygen. And the first 20 elements of the periodic table are what it is that we need to study. We need to know them. We need to know the first 20 elements. We need to know the mass number. We need to know the number of protons. We need to know the number of neutrons. We need to know the electronic configuration. And it's not difficult to study. Like the mass of oxygen is 16, right? And the atomic number is 8. And because you know the atomic number being 8, you can write the electronic configuration, 2,6. And from that 2,6, now you can say, wow, in order for it to reach a stable octet, we need 2 more electrons. So therefore, it is going to be an ion, and it is going to be charged. So therefore, because it needs 2 more electrons, and because hydrogen, for argument's sake, has only 1 electron on its outer shell, that's why the molecule of water is H2O. Because oxygen needs 2 of something to call it quits, so that it becomes stable. So all of these things, the basic chemistry stuff, we are going to be doing, you need to know them. You should be able to write a balanced equation. You should be able to write a reaction. 2 compounds coming together, you're supposed to be writing the reaction. This is a double decomposition reaction. This is a redox reaction. You have to be able to write those. You should know it. Okay. So a solution is a homogeneous mixture composed of two or more substances. We spoke about this last class. In such a mixture, a solute is dissolved in another substance known as a solvent. Remember, I spoke to you about solute and solvent?
Yes, sir.
Yes, sir.
The solute is what is being dissolved. See it right
And
here, so I
this,
told you already.
yeah,
And then,
and the solvent is what is doing the dissolving.
very good. So I'm not going to spend any time on that. We're going to look at solubility. A solid is considered soluble if it dissolves readily in a given solvent. You remember we did the potassium story and the nitrate story, sodium nitrate. Once it is that the solid dissolves readily in a given solvent, it means that it is soluble. So I may have a solvent. A solvent is what is doing the dissolving. But the solute don't, say my solvent is water, and my solute is whatever it is. And the water now dissolve it. No problem. I may use alcohol, and the alcohol dissolves it. It means that the perfect solvent for that particular solute is going to be alcohol. Once it is that you have it dissolving readily in it, it means that it is soluble. So a sparingly soluble substance dissolves only to a small extent. So if something is sparingly soluble, is only some of it dissolving it, and it leaves the other solvent. So you may put in a mass of 10 grams, and of the 10 grams is only 3 grams dissolve out. You call that solution sparingly soluble. Sparingly soluble. And this is what I wanted to look at. I told you a story about. All right, so this is my solubility curve. Mikey spoke about temperature, so did Asia spoke about temperature. I mean, all know temperature increases the rate of a reaction. All right, spoke to you about something, and it happened to me today. So I drew my curtains in my bedroom. There were lots of sun coming in. I said, sure, yeah, if it's the place can air out, not a problem. And then I went to another section of the room to spray my aerosol can that I use as a deodorant. You know what happened to me? The first couple of sprays, there's liquid in the can now because I can't feel it. The first couple of sprays is just pure air coming out. You know what happened there? The liquid particles, the gas from the can started to expand and expand and expand. So me take up that tin of spray now to spray. It is releasing the extra gas particles inside of it. You can see that? It makes sense?
Yes, sir.
Yes, me a spray and nothing now come out. And there is liquid in it. There is liquid in it. So we have to do that. Anyhow, this is the solubility. Grams of salt in 100 grams of water. Grams of salt in 100 grams of water. My NO3s are what? My what? NO3 is what? We're going to introduce.
Oxygen and
No, man. Remember, we introduced it the other day, man, and I said to you that.
My favorite salt,
Huh? No, not this, not the table salt. No, not the table salt one. The
Sodium
NO,
something.
sodium what? And I said to you that all
Nitrate, oxide,
right, nitrates.
sorry, nitrate.
Right. So remember I said to you that all nitrates are soluble. Look at the solubility of sodium nitrate.
Oh, yeah.
70 mash of it, about 73 of it, grams of sodium nitrate will dissolve in 100 grams of water. That's what it means. So this is a solubility of the salt in 100 grams of water. So if you look at the sodium nitrate, if I put some sodium nitrate into a container containing some water, 70 plus grams of what I put in there is going to dissolve. Now, what will happen? If I put potassium chlorate or potassium permanganate 7, K2Cr2O7 is potassium permanganate 7. If I put some potassium permanganate 7 into water, it's about 5 grams going to dissolve in it in 100 grams of water. Can you see that?
Yes, sir.
Yes, sir.
My potassium at 0 degrees. Important to say at 0 degrees. At 0 degrees. When I increase the temperature, the reaction goes faster. Now, at 0 degrees, my potassium nitrate is about 13, 14. I don't think it reached 15 yet. At 0 degrees. But at 10 degrees, it's about 20. At 20 degrees, it is 30. At 30 degrees, it's about 45. At 40 degrees, jump to 65. Yo, you see, by the time it reached 50 degrees, it jumped to 90. So this is very steep, this potassium nitrate. Look at lead nitrate. Lead nitrate is increasing with increasing temperature. By the time it reached 65 degrees, 100 grams of it is dissolved in 100 grams of water. All of it is dissolved in 100 grams of water. Calcium chloride also has a high solubility rate. And calcium chloride is found in our water pipes. Because remember, now we have calcium carbonates as our limestone. True or false?
True.
Mm-hmm. And, like I drove, over an aqueduct today in Mona, and the water that is coming from our stream or river is actually running through, and it's picking up these minerals from the earth. So your aluminum carbonate, your sodium carbonate, your calcium carbonate, it's picking up all of these things and it's dissolving. So when you see the white precipitate inside of your kettle, what do you think it is? Hmm?
The calcium chloride.
Yeah, and a lot of people call it chlorine. And sometimes it's a carbonates too, right? And a lot of people call it, oh, sorry, the chlorine. It is not chlorine, it's a carbonate. So what you can do is just treat it with some vinegar. So treat it with some vinegar. Put some vinegar in there and then or your acetic acid, which is the correct name for vinegar. And when it treated with acetic acid, and you heat that kettle gently with some vinegar inside of it, it's when it dissolves, you have a brand new kettle. You have a brand new kettle. Right? So this is what it is. So those are some solubilities that we're looking at that we can use to determine things like or fertilizers. Which would be a good fertilizer to use? and potassium nitrate, the one in green, because I need the potassium for the plants to grow, NPK. And because the nitrates they are soluble, my potassium nitrate is good. I don't want any sulfates. Potassium sulfate is not something that I want because the sulfates now when they become acidic. Because that sulfate now when you put water to that, it forms a weak sulfurous acid. And that's what causes acid rain as well. So you don't want that to happen. All right. All right, guys, I'm going to stop there because I'm cognizant that we have another session with Dr. Gudapati at 7 o'clock. So I'm just going to ask that you read for me, please. You have to read, students. You have to read. Have a good one.
All right,
All
sir.
right,
Thank
Same
sir.
to you
you, sir.
next
Have
week.
a great weekend.
Yeah, cool. You too.